Hey guys, Mr. Manhot here. Let's do some inverse functions. So directions here are to graph the function that we're given, find its domain and range, find the inverse of this, graph it, and state its domain and range. So let's graph first. So this is just a linear, this is a straight line, right? Y equals mx plus b. So we're going to start here at -4. The slope is up 1 over 2. It's a straight line, so you can continue that pattern up 1 over 2, or if you're going backwards, down 1 and to the left 2. That looks probably good enough. Draw yourself a line. And there we go. Pretty good. Okay, domain and range. Remember, domain is your x values, range is your y values, or input and output. So what's cool about these linear straight lines is that they continue on forever in each direction, right? Since it has a slope and it's going up in this direction, down and going to this direction, and it's also continuing on horizontally, the domain's going to be negative infinity to infinity, and the range is also going to be negative infinity to infinity. Because if I go way back here, right, off my graph, imagine this is negative infinity back here, I could go down far enough and it'd hit my graph. It may be way far if we're way off the graph, but we could get there. Same going in the positive infinity direction. Same going on the y-axis, way up here, positive infinity on the y. I'd have to go way out here, but eventually the graph would hit that. Same in the negative direction. Let's find the inverse. We can skip a few steps. Remember, we replace this with a y because they mean the same thing, and it's easier to write a y. You have to move your pencil more times to write f of x than to write y. So let's use y because it's easier. And so you replace it with y, and then you swap, or you invert the x and the y. So we'll go have this. X equals 1/2 y minus 4. So we replaced the f of x with an y, and then swapped their places. Now, solve for y. We want to get y by itself. So the first thing you do, add 4. X plus 4 equals 1/2 y. How do you undo a 1/2? Well, this is just times a half, so you could divide by a half, but what's easier to get a half to become 1 is if you just multiply by 2. Right? Half of 2 is just 1, so you just are left with y, or 1y, and you can distribute here and get 2x plus 4. So you're pretty much done here. Let's use the correct notation. Let's be extra clear that the inverse of x, f inverse, or the inverse of f, sorry, f inverse is 2x plus 4. So there's the inverse. Let's graph it. We start at +4, and the slope is up 2 over 1. So up 1, 2 over 1. And we'll do a couple of dots. We'll go down this way. And I bet you, if I was careful, I am going to bet that these intersect at a nice spot. There we go. And if I were to draw that inversion line, the y equals x line, it would go right through that point as well. Okay, the slope is different than our original f of x line. The slope is different, but the domain and range is still the same, right? We could still go way out here to negative infinity, hit our graph. Way out here, positive infinity, hit our graph. Same in the y direction, both positive and negative. So the domain and range for this one is also negative infinity to positive infinity. Pretty good. Okay, not too bad when they're straight lines. Let's look at another one when they're not going to be a straight line. This is a square root, right? The square root of x plus 1 plus 5. Remember this? We were struggling on this on a quiz. The graph looks kind of like half a parabola, a little arc. Starting point would be up 5 and to the left 1, right? Opposite sign of what's tucked in there with the x. There's no coefficient out front, so the next point would be over 1, up 1, and it's going to look something like that. Okay. Now let's look at the domain and range from this one. Domain x, range y. The smallest x value that still lines up with our graph. Well, I'm thinking right here. That's the smallest x value that still hits our graph. Anything back here, there's no graph there to hit. This is the first one, right at -1. Use a hard bracket. Now this graph continues on in the x direction, so we'll say to infinity and beyond. Range? Well, range is the y value, so let's look at the y values. The smallest, or the first y value that lines up with our graph is right here at 5. This should kind of make sense from the equation, because remember, this is like the coordinates of your vertex, the x, y coordinates of your vertex, and you got x, y, right, like your domain and range. And this graph does continue up. I mean, it will flatten out like this, but it'll be still increasing just ever so slightly. Infinity. Let's find the inverse. Replace this with a y, swap places with the x, or invert with the x. So we'll have this. Be careful, this 5 is not underneath the radical sign. Common mistake if you're sloppy with what you're writing. It's not under there. Let's solve for y. Minus a 5 on both sides. Cool. Okay, so now we got to undo a square root sign. I mean, when we're finding the inverse of a function, you do inverse operations, right? The inverse of +5 is -5. The inverse of square rooting something is squaring something, right? Those undo each other. So you've got x minus 5 squared equals y plus 1. And we have one more step. The inverse of a +1 would be a -1. And I think you guys are good to track along to write our final answer here. I mean, we'd have y by itself, and we'd have x minus 5 squared minus 1. Leave it like this. This is vertex form of a parabola. We can graph this pretty easily. The coordinates for the vertex would be at -1, +5. Right, from our x, y, or I'm sorry, I said that backwards. +5, -1, but I read it as I was going from there. And there's no coefficient, so the slope from the vertex to that next parent point is just 1/1, and it kind of looks a little something like that. All right, let's talk about the domain and range of this one. Domain, x values. Well, this parabola, it continues on, like it is always widening. We've talked about this before. So it will be -infinity to +infinity. Range, let's see, where's the smallest y value? I'm seeing right here is the smallest y value that lines up with my graph. All of these ones, there's nothing that lines up with, the graph doesn't even go down here. So it starts at -1 and continues on to infinity. Now, do you notice that the domain of our function became the range of our inverse? That kind of should make sense, right? Inverses talk about switching things. So the domain becoming the range should kind of make sense. But how come these two did not exactly switch? Think about that a little bit. Right? Can we have any negative numbers under the square root sign? Not with, I mean, we know about imaginary numbers a little bit, but if this graph is just showing all real numbers, there's no real number that could be, you could take the square root of if it's negative under there. So our original function gets limited at 5, because anything below there, it would be a non-real answer. But when we invert it, when we flip it, we open it up to all real answers. Kind of interesting. But if you can do the graphs, and you can do this, finding the inverse, you're good. All right, guys. Come to class with questions next time. Hope to see you at student-led conferences. Remember, we're mathematicians. We can do anything we want. See ya.